Hello, this is Julie Hudson. I am with Team 12, NASA Psyche Mission Space Object Virtual Reality. I'm going to go over the Python that we have used to interface with SpicyPy and pull more information from the Spice data, the kernels. So one of the first things, one of the programs that we created this sprint is the solar system planets.py, which can extract the any information as far back as 1500 BCE and as far forward as 2150 CE. So I'll go ahead and demonstrate that right now, just to show. We'll say February 22nd, since that's today, and let's set it at 8 p.m. So that would be, I believe, 20. All right, so these are the exact positions of the different planets in relation to the sun. And for future, we might tweak this to be around the sun's barycenter, so we'll have the sun wobbling as well. But this is our current positions, as well as distance from the sun, which is pretty neat because it's very, very exact. And we've also extracted the information in regards to the shoemaker. So we can get the shoemaker's distance from Eros. So let's look at 2001, February 12th, and we'll look at 1 second past midnight. And as you can see, this is when the near shoemaker was getting really close to landing on Eros. Perfect. All right, and up next, another one of my wonderful teammates will talk to you about other features that we've added to our cool VR experience.
Hello. So in this sprint, we reconstructed the level 3 map of Eros, which is the ancient ridge part of Eros. We also fixed certain invisible collision issues that were going on within the levels. And then with our static meshes, we have added these LOD groups right here. And what this does is LODs are level of details, and in this top left corner you can see we're on LOD 0, shows the current screen size that the mesh is taking up of the screen, the number of triangles, vertices, and as we zoom further out, if this was in a game, this LOD will change per the screen size that it takes up. So right here, just change to LOD 1, and this uses less triangles and less vertices, so we can better optimize the objects within our games. Thank you.
Hey, this is Nate, and in this sprint, we made some pretty good progress in the 3D modeling portion. So one of the things that we added was this Earth and Sky Sphere into the gallery view. With this Sky Sphere, you can see all the stars in any direction that you look. We also added the gallery base here, which is going to display different models above it. We had a little trouble adding the gallery controls, but they are close to being added. We also had some trouble with the materials not showing up quite right, so we had to reset some of the Megascans MS default material to fix that. Then we also added some textures here that will be used to, we'll apply those to different spheres, and then we're going to use those for the different planets. And then we also were able to import the International Space Station as one mesh. Thank you.
This is Ryan. For my portion, I had two main goals for this sprint: to add features that would make a new iteration of the demo and to put that demo together throughout the sprint instead of all at the end. And for features, I implemented the scanner feature where you can see I am not able to do it yet because of the unlocking feature. But you scan an item and reveal the gallery item beneath. And then whenever you're done playing with it, you have your unlock message, which is the notification system. And this wrist menu is another feature that we added. The other portion was to package everything and put it together for the demo. This involved going through all of the directories and the different types of content we have, whether it is maps or blueprints or assets or images, and reducing the package size as much as possible, and then going through and packaging the project. So doing that at 3 different stages during the sprint kept us from being quite so steamrolled at the end.
This is Eric Sogstad from Team 12 Space Object VR. During this sprint, we spent quite a bit of time creating the maps for our virtual reality experience. We collected multiple images from NASA of the Eros landscape and also its color. We then created our own landscape and texture based on those images, as you can see here. On the left are the pictures from NASA, and then our generated images on the right that we created. We then took the multiple slices that we took out of Eros for our maps and transferred that landscape over onto them. And we also modified these maps with craters and rock assets so that they would match the images provided by NASA.